Well, my calculus folks, let's see what we remember. So here we have a bunch of lines that are slapped together, and we're calling this graph f prime. So this is the graph of a derivative, right? These are the slopes of some function f. Okay, so here we have positive slopes, down here we have negative slopes, here we have positive slopes again, and there we have some negative slopes. Okay, so we know that f of 1 equals 3. So on our function, on our original function, when x is 1, y is 3. Okay, so that point on your original function is like right there. That goes with f, right? That is not a part of our graph. That goes with f. So, consists of two semicircles, two line segments as shown to the right. Find all values where f has a relative maximum. Okay, or f has a relative maximum. So we have to know that a relative max happens once our graph stops going up and starts going down. Right? We're walking up the hill, we get to the top of the hill, and then we walk down the hill. So we need to have increasing y values followed by decreasing y values. So what does that mean for our derivative? Well, we have positive derivatives if our function is increasing, and we have negative derivatives if our function is decreasing. Okay? So we want to find out where our derivatives change from positive to negative. And that happens here at -3. Our derivative changes from positive to negative. And that also happens over here at +4. Our derivative changes from positive to negative. Okay, so we don't know which one is higher. We don't know the y values at these places, but we do know that the graph has a relative maximum at those two values. So this is the complete sentence with justification because f prime changes from positive to negative there at our points -3 and +4. Okay, so now we're looking at B. At what values does the graph of f have a point of inflection? Okay, so a point of inflection happens when f double prime changes signs also. Changes signs. Okay, so where might this happen? This might happen at the relative maximum or a relative minimum for your graph. Okay, so we have three potential places where we have points of inflection. So f double prime is the slope of your f prime graph. Right, so we have an f prime graph. Here our slopes are positive, and then we have negative slopes. Right, so that means that our derivative changed signs. We went from positive slopes to negative slopes. And down here we have negative slopes that change to positive slopes. And here we have positive slopes change to negative slopes. Okay, so f changes from increasing to decreasing. Sorry, f prime, right? These y values are increasing up to -4, and then they become decreasing, which means our second derivative has changed signs from positive to negative. And then here we have decreasing y values to increasing y values. And once again, we have increasing to decreasing. Okay, so here is what you should write on your paper. So it's important to use f prime in your justification. Okay, because we're given the graph of f prime, and that's all that we know. So we use f prime in justifying our 3 points where we're going to have inflections for the graph of f. Okay, so f prime changes from increasing to decreasing, which means we have a change of sign of f double prime, and then it has decreasing to increasing. F double prime changes sign there also. Okay, and our last one, when our f is concave up. So that means that f double prime is positive, right? We have to have positive slopes in order for it to be concave up. So let's look at our graph. So that happens from -5 to 4. That's where we have positive slopes. It happens from 1 to 2. right, we also have positive slopes. Okay, yes, it's below the axis, but the slopes for f double prime, right, that would be the slope of this graph. So when are the slopes of f prime positive, right? When is our y values increasing? So right now we're looking at from -5 to 4 as an interval, and from -1 to 2. So that's where it's concave up. But then where does it also have a positive slope? So where is this graph above the x-axis? Well, it's above the x-axis from -5 to -3, and it's above the x-axis from 1 to 4. So the answer is the places where these things overlap. So they overlap from -5 to -4, and they overlap from 1 to 2. So how would we write that in a complete sentence? Let's talk about that right now. Okay, so here is why it is concave up, right? Because this is dealing with the second derivative. If f prime is increasing, then our second derivative is positive, right? But we're not saying anything about our second derivative, only the first. And because f prime is positive, which means we have positive slopes. Okay, number 2, we want to find a point of inflection, right? That happens when the second derivative equals 0. So we have to take 2 derivatives of our equation here. Okay, so first we have y prime, and thank goodness this is a polynomial, so we can take care of this one pretty quick. There's our first derivative, and then our second derivative, 2x plus 10. And we want to know when is that equal to 0. When is our second derivative equal to 0? So we just solve that for x. Okay, let's see what else do we got here. If x squared plus xy equals 10, then what is dy dx? Okay, so this looks like, because we have a y in here, this is going to be implicit differentiation. Right, so we're taking the derivative with respect to x, which is pretty okay for our first value, x squared. What's the derivative of x squared? Well, that's just 2x plus, now we have x times y. So we're going to use the product rule for x times y. So f prime g plus f g prime. Okay, so the derivative of x is 1, so that's 1 times y, plus normal x times the derivative of y, which is y prime. So this is our implicit derivative of x squared plus xy equals 10. So now, since we want to figure out what dy dx is, I need to plug in x equals 2. Well, I just need to solve this for y first, right? Solve this for y prime. So I'm going to subtract these two things to the other side and then divide by x. So y prime is -2x minus y divided by x. Okay, so that's how I'm going to find the slope, which is your first derivative of any value here. Okay, now here's the problem. How many letters do I have in my slope? 2 letters. And what letter do I know? I know that x is 2, which means I am missing the value for y. So how are we going to figure out what y is? Well, we got to come back to our original thing and plug in x equals 2. So 2 squared is 4 plus 2y equals 10. Okay, so in order to figure out what my y value is for my dy dx, right, because it has a y in it, I have to find out what the value of y is from your original equation. Okay, so if I solve this for y, I get y equals 3, right? I minus 4 from both sides. 10 minus 4 is 6. 6 divided by 2 is 3. So I can come over here now, and instead of a y, I'm going to put 3. So now let's do my simplification. -2 times 2 is Negative 4 minus 3 divided by 2 is negative 7 over 2. Negative 7 over 2. There it is. The answer is A. Okay, number 4 is a particle motion question. And we want when is the velocity 0, so you need to know that the velocity is the derivative of position, which is 2t minus 6. Okay, the derivative of t squared minus 6t plus 5 is 2t minus 6. When is that equal to 0? When t equals, when t equals 3, because we add the 6 to the side and then divide by 2, and I get a velocity of 0 when t equals 3. Okay, the bell rang, so it's going to be loud. But let's look at this one. Twice differentiable function, which of the following is true? Okay, so we know that our graph of f, so f of 1 is 0, right? That's the y value of f where it crosses your x-axis. So f of 1 is 0. But let's see about the derivative, f prime, right? So looking at this, the derivative, what would you say about the slope of that tangent line? Well, I would say that the slope of that tangent line is positive, right? Maybe it's 1/2, maybe it's 5/9, right? I don't know what it is, but I do know that it's positive. So the positive number is greater than at least a 0 number. And what can we say about the second derivative? Well, I know that this graph is concave down, right? This is a concave down graph. If water were to fall on it, it would spill out. This is concave down. And I know that if my function is concave down, then my second derivative is negative. Right? I don't know what the value of it is, right? If it's negative 2 or negative 7 or negative 45 million, but I do know that it's negative. Okay? So 0 is greater than a negative number, but 0 is also less than a positive number. So that's what I'm looking for. F double prime is less than F is less than F prime. And that looks like the correct answer would be D. Okay? So there is some study help. Hopefully that helps increase your brain, especially how we write and justify these things based upon the graph that we're given.